Assalamualaikum and hi everyone. My name is HUSSIN bin ANSAHARI and my matrix number is 200530. Now, I want to explain about the question 7b of assignment 6. The question asks to evaluate of integral function where C denote the boundary of the square whose sides lie along the lines x equals to plus minus 2 and y equals to plus minus 2. So the question given is contour integral cos z dz over z power of 2 plus z. So the first step is we need to find the singularity of the contour equation, this equation. So to do that, we need to factorize the denominator part and become this contour integral cos z dz over z in bracket z plus 1. So with this, we can get the singularity of the function, which is z equals to 0 and z plus 1 equals 0 and z equals to negative 1. So the singularity of this function is z equals to 0 and negative 1. So the next step is we need to calculate the range of modulus to determine whether the singularity is inside the range or not. So this modulus equals to square root 2 power of 2 plus 2 power of 2. This value is we get from the equation x equals to 2 and y equals to 2. And we get this square root x which is 2.8. So because the singularity of this function is 0 and negative 1, which is inside the modulus 2.8, so we need to calculate the residue of each singularity. Then we need to calculate the residue of z equals to 0. Limit z approaching 0 in bracket z cos z over z in bracket z plus 1. So this z and this z we can cut. So we get limit z approaching to 0 cos z over z plus 1. And we just substitute the value of z with 0 and we get 1 over 1 and 1. So the residue of z equals to 0 is 1. Then we need to calculate the residue of z equals to negative 1, which is limit z approaching to negative 1 in bracket z plus 1 times by cos z over z in bracket z plus 1. So z plus 1 this and z plus 1 this we can cut. And we get limit z approaching to negative 1 cos z over z, and we just substitute the value of z with negative 1 and we get this negative cos negative 1. So this is the value of residue of z equals to negative 1, which is negative cos in bracket negative 1. And lastly, after we got the answer for residue of z equals to 0 and the answer for residue of z equals to negative 1, we use the formula of contour integral theorem, which is 2 pi I times by the summation of residue within x, and we get this 2 pi I in bracket 1 minus cos in bracket negative 1. So this is the final answer for this question. Thank you. That's all from me.